Let us understand how the Numpy looks in the memory. See, every Numpy array will have these attributes in the memory. What actually these attributes are? This is an array. Now, in addition to this array, there will be some metadata get stored. This metadata as compared to the list is very less. We already knew what exactly is the problem with the list, because list requires for every element huge metadata. But here with respect to the Numpy array, the metadata is very less indeed. But still, since it is going to store some more elements, we are in a need to understand all those other elements in addition to the ND array object. This is an array. This is the array object in the memory. In addition to which, what will get stored with respect to this array? The first thing is the array itself. The second thing is a data pointer. What is the data pointer? Data pointer is going to be holding the first address of the array. For example, this array is starting from 200 location. So this data pointer holds the address of this array, starting location of the array. Now, it also is going to hold the data type of this array. Since Numpy array only is going to hold the elements that belong to the same data type will be specified here. The data type will be 1. And the second one is shape. The shape will be specified here. The next thing is stride. What exactly you mean by the stride? From one element to the other element, how many bytes I need to cross? From one element to other element. Rather, from one row to another row. What should actually be the stride? We're going to understand more about this stride in some time, but what is the stride? In order to jump from one, let us say, each element is of 8 bytes. Now, in order to move to my next elements, I need to move for 8 addresses, right? Next address is at 208. So, to move from here to here, I require to move for 8 words. So, this is a stride. The stride I am taking from the first word to second word. Similarly, stride also can be taken from first row to second row in a 2-dimensional array. Similarly, stride can be taken from first row of the first page to the first row of the second page in 3D array. So, this stride exactly is going to tell you how many bytes you just need to move whenever you're moving across this array. Maybe from word to word, or first word to the second word, first word of the first row and first word of the second row, or from the first row of the first page to the first word of the first row in the second page. So this stride is going to tell you exactly how many strides you need to take. Next, flags. There will be several flags. Is writable. What is writable? Writable flag meaning, writable flag tells you that would this array be updated? How the array is going to be updated? Aligned flag meaning, is the array actually properly aligned within the memory with respect to the hardware? You have less transparency to this. You don't need to completely understand what exactly is this align, but still I am going to explain this align in the upcoming sessions. Update if copy. What is update if copy? When you create a new copy, how this array is going to be updated? These are the details that are going to get stored with respect to every array. Now, let us clearly have a look at what exactly is the writable, align, update if copy. These flags. Now the thing is writable. What do you mean by writable? Writable meaning, writable generally is used to be 1. Usually it will be equal to 1. When writable is equal to 1, then you will be able to create the changes. You will be able to make the changes within the array. The array what you just have created can be updatable. You will be able to perform some manipulations. If it is equal to 0, which is customized, by default it will be equal to 1. That allows you to manipulate the elements of the array. If it is 0, you will not be able to manipulate the elements of the array, but you should be able to set this flag to 0 manually. But by default it will be equal to 1. What is aligned? Aligned meaning, is the array actually being aligned with the architecture size? For an example, if you do have a 32-bit architecture size, this array must properly be aligned to this 32-bit architecture. In a 32-bit architecture, one word size is equal to 32 bits. In a 64-bit architecture, one word size is equal to 64 bits. We don't actually require these in detail about this align. This align will simply talk about the how array is the array completely aligned with the architecture level. The third one is update if copy. What is update if copy? For example, I just have created ARR1. Okay. And the second thing is I just have created ARR2. Now, when I say ARR2 is equal to ARR1, what you are going to expect? Similarly, simply in the simplest words, ARR2 is a new array, right? Which is going to hold the values of one array. That means whenever I have created an array and I want to create a copy of the array in ARR2, one more replica of the array is going to get stored. In the memory, I do have ARR1 here and ARR2 here. Both values are one and the same, right? That only is possible when the update the copy if it is equal to 1. If the update the copy if it is equal to 0, if this flag is equal to 0, when I say ARR2 is equal to ARR1, new copy will not get created. Rather, this ARR2 is another identifier to ARR1. Same array now is going to be represented with two names. That's it. If the update the copy flag is equal to 1, and if you want to create a replica of this array, one more memory image of this array will get created. And if you don't use it, what exactly is going to happen? If the update if copy flag is equal to 0, then what might be the problem? The problem will be is new copy will not get created. If you say ARR2 is equal to ARR1, we just are going to use another reference to identify the same array. We just do have two names through which we'll be able to identify the array. As simple as this. If you are able to make one change in ARR1, same ARR2 will also have the change, because both ARR1 and ARR2 actually referring to the same array. That is what? Update if copy. Yeah. To create, we'll have various methods. What are the methods? Sum, mean will be able to calculate a sum, min, max will be able to calculate a sum, will be able to calculate a mean, the smallest element, the biggest possible element, var, arrange, reshape, will be able to manipulate the elements of the array by using various functions that are inbuilt to the Numpy arrays.